Hello, Provisory students, and welcome to the Notes on Factoring by the Greatest Common Factor, otherwise known as the GCF. Alright, so let's start off by looking at example A. We want to find the greatest common factor of 18, 36, and 54. So what that means is we want to find the largest number that we could divide 18 by, 36 by, and also 54 by. So what's the greatest number they could divide all three of those numbers by? If you know your multiplication facts, then you might look at them and say, oh, it's 9, and you're done. You found it. But if your if you don't see that's 9 visually, then I'm going to show you a method that could be used in order to find your greatest common factor. I'm calling this the ladder model. So what you're going to do is you're going to put all the values or terms that you want to find the greatest common factor for in here. It's kind of like a step. And now I want to find a number that I could divide each of them by. And we're going to start off with the smallest numbers and work our way up. So 2, 3, 4, 5, 6, 7, 8, etc. 18, 36, and 54 are even. And for every even number, you could divide that by 2. So I could divide it by 2, so I'm going to divide it by 2. 18 divided by 2 is 9. 36 divided by 2 is 18. And 54 divided by 2 is 27. Now, see if you could divide 9, 18, and 27 by a number. See if you could do it by 2 again. Well, the issue with that is 9 is an odd number. And all odd numbers, you cannot divide an odd number by 2 and get a whole value. So 2's out. What about 3? Does 3 go into 9? Does 3 go into 18? Does 3 go into 27? If you are not sure, take out your calculator and go 9 divided by 3, see what number you get. Take 18 divided by 3, see if you get a whole number. Take 27 divided by 3, see if you get a whole number. When you do that, you will see that 9 divided by 3 is 3, 18 divided by 3 is 6, 27 divided by 3 is 9. So I could factor out the 3. Once again, now I have the numbers 3, 6, and 9. Can I divide 3, 6, and 9 by the same number besides 1? And the answer is yes. 3 goes into 3 1 times, 3 goes into 6 twice, and 3 goes into 9 3 times. So then I have these values left. I have 1, 2, and 3. Once I got the value of 1, the only number that I could factor out from 1 is 1, so I'm done there. Now the key here is these 3 values that are vertical will give you your greatest common factor. So my greatest common factor over here will be whatever 2 times 3 times 3 is. Find that product. 2 times 3 is 6. 6 times 3 is 18. 18 is my greatest common factor. Let's look at example B. Once again, I have 28, 42, and 56. I'm going to put down my first rung of my ladder. And since those numbers are all even, I could divide that by 2. And if you're not sure what it is, use your calculator. Go 28 divided by 2 gives you 14. 42 divided by 2 is 21. And 56 divided by 2 is 28. So now, I go down, I'm going to look at 14, 21, and 28. So, my different values I'm going to look at is, let's try 2. Does 2 go in 14? Yes. Does 2 go in 21? No, because 21 is odd. So that's out. How about 3? Can I divide 14 by 3 and get a whole value? No. And once again, if you're not sure, put in your calculator, go 14 divided by 3. See if you get a whole number. If not, that's out. Well, if 2 doesn't go in 21, any other even number like 4, 6, or 8 will not go into 21. 5, well, only numbers that end in 0 or 5 have a factor of 5. So 5 does 14 does not, I mean 5 does not go into 14 a whole number of times. 7. 14 divided by 7 is 2. If I go my calculator, I go 21 divided by 7, I get 3. And I go my calculator, I go 28 divided by 7, I get 4. So 7 is a factor, common factor. And then I look at this last rung there. I got 2, 3, and 4. 2 goes into 2, but not into 3, and that's my largest number there. So none of the other numbers like 4, 5, 6, or 7 are going to go into 2. So my greatest common factor for example B will be the product of 2 and 7, which is 14. It does not matter if you're trying to find the greatest common factor of 2 numbers, 3 numbers, 4 numbers, 5 numbers, 6 numbers, 7 numbers. This latter method will work. So let's look at example C. We got 15, 30, 75, and 105. Well, I see that each of these numbers, like 15 ends in 5, 30 ends in 0, 75 ends in 5, 105 ends in 5. So I know I could divide each of them by 5. 15 divided by 5 is 3. 30 divided by 5 is 6. 75 divided by 5 is 15. And 105 divided by 5 is 21. Now, do my next rung. I have 3 here. The only number that goes in 3 besides 1 is 3. So the question is, can I divide 6 by 3, 15 by 3, and 21 by 3 and get a whole number? And the answer is yes. And once again, if you're not sure, take out your calculator and go 3 divided by 3, that gives you 1. 6 divided by 3 gives you 2. 15 divided by 3 gives you 5. 21 divided by 3 gives you 7. And now, in this rung, all these numbers are prime. The only numbers that, well, let me rephrase it. 1's not prime. Prime numbers begin with 2 or greater. But the thing is, you can't, there's no number besides 1 you could divide each of those numbers by. So the greatest common factor will be the product of 5 and 3, or 15. Now in example D, we're adding variables on. And we're going to handle it the same way we were doing before. So I'm going to put down each of those terms with the variable. I'm going to put my rung. I'm going to ask myself, looking at the numerals, the constant values, the coefficients, 12, 15, and 30, does 2 go in each of them? The answer is no, because 15 right here is an odd number, and 2 does not go in an odd number an even amount of times. So 2's out. How about 3? If I take 12 divided by 3, 15 divided by 3, and 30 divided by 3, will I get a whole value? Yes. I'll get 4, 5, and 10. Now, can I take away one or more C variables? Can I factor that out? Well, I have 3 C values right there that I'm multiplying together. Here I have 2 of them. Here I have 1. What's the most I could take away from each term? Well, here I could take 3 C's away, but I cannot take 3 C's away from this nor this because I don't have enough. So the maximum numbers of C's I could divide from each of these 3 terms is only C to the first. Only 1 C. And when I divide this by 3C, 3 goes into 12 4 times. But this 1 C here will cancel out with one of these C's. So this will be C squared. When I divide this by 3C, 3 divided by 15 divided by 3, I mean this is 5 here. But there I got C squared divided by 1C. That means one of these, out of these 2 C's I'm multiplying together up in my numerator, I'm going to cancel out one of them, so I end up with a C. And then if I divide this by 3C, 3 goes in 30 10 times, which we have here, and these c's cancel. So my greatest common factor is simply 3c, because 4, 5, and 10 have no number besides 1 in common as a factor. So now let's actually factor out the greatest common factor from a polynomial. I'm going to use that ladder method as I was doing, but this time I'm going to put down 21x, and then I get the plus 14. And once again, what can I factor out each of these terms? What's the greatest value I could divide 21 and 14 by? You could try 2, 3, 4, 5, 6, 7, 8. So if 21's an odd number, so 2's out. 3 does go into 21, but 3 does not go into 4 evenly. Since 21's an odd number, all even numbers are out. 25 divided by 5 will be 4.2, so that doesn't work. 7 goes in 21 3 times. 7 goes in 14 2 times. And then the question is, can I also pull out an x? Well, I have an x in this term, but I do not have an x there, so x is not common, so you cannot pull out with your common factor. So I bring that x down. So my right here is one factor. Right there's the other factor. So 21x plus 14 can be rewritten in factor form as 7 times the quantity 3x plus 2. So this right here will give you one of your factors, or if you have multiple steps, that greatest common factor will be one of these factors, such as this one. And what remains here after you get in prime form will be what you're factoring out, and that's the quotient, so to say. And you get that. Let's look at f, and then we'll talk about exactly what it means to factor. So we got 42x squared minus 30x plus 12. I'm going to start seeing how I can factor it. Once again, if you can identify the greatest common factor by just looking at the 3 different values and knowing your multiplication facts, then do it that way. But if you cannot, then let's do this approach with the ladder. So I got 42, 30, and 12. They're all even, so 2 goes into it. I got x squared here, I got x, and I got no x's here. So I cannot factor out an x variable. That's not common. X's are not found in all 3 of these terms. So all I could do is divide each of those terms by 2. When I do that, I get 21x squared minus 15x plus 6. And once again, I look, can I factor this even more? 21's an odd number, so 2 or any multiple of 2, such as 4, 6, 8, 10, etc., won't work. So let's look at 3. If I take 21 divided by 3, I get 7. If I take 15 divided by negative 15 divided by 3, I get negative 5. If I take 6 divided by 3, I get 2. Don't forget the variables because they're going to come on down, and I divide those by 3. Now I have this right here. I got 7. 7's a prime number. The only number goes in 7 is 7 and 1. So I could divide the first term by 7, but can I divide 5 by 7 and get a whole number? No. So we are done. So this is my greatest common factor, the product of that. So that would be 6. Hence 42x squared minus 30x plus 12 equals, in factored form, 6 times the quantity 7x squared minus 5x plus 2. And there's our answer. Now, what it means to factor, basically we're doing the inverse of distributive property. Distributive property, we took the number in front of parentheses and multiplied it through the parentheses. The quantity in front was 6. So we were multiplying each term by magnitude of 6. And when I do that, I get 42x squared minus 30x plus 12, which is exactly what we started with here. So factoring is an inverse of distributive property. All right, so let's try this one. I'm actually going to do a little shortcut. I'm going to start here. And I'm going to ask myself, what can I divide 20, 36, and 54 by? Well, they're all even, so 2. Then I ask myself, when I look at the variables, does each term have the same variable? It does. So they have x in common. The question is, what's the most number of x's I could take away from each one of those terms? And the answer will always be the x to the smallest exponent. I have x to the first right there. I could take away 1x from this one, and I could take away 1x from this one. So I'm going to factor out x. Now let me kind of clean this up a little bit. There we go. So if I take 20 divided by 2, I get 10. And if I take x cubed divided by x, I'll get x squared. Because one of the x cubed x's will cancel. Then I got plus 36 divided by 2 is 18. And that x squared divided by x will leave me with just x to the first. Minus 54 divided by 2 is 27. And then, like if I do this, put the 2x here, these x's will cancel, so it just leaves with 27. Now, let's see if I can factor anything else out. I got 10, I got 10 right here. I could divide 10 by 2. I could divide 18 by 2, but I cannot divide 27 by 2, so 2's not in. 3, 10 divided by 3 is not a whole number. 4, 10 divided by 4 is not a whole number. 5, 10 divided by 5 is a whole number, but 18 divided by 5 is not. 6 won't work, 7 won't work, 8 won't work, 9 won't work, 10 won't work. It looks like we have run out of common variables, or common factors. So 20x cubed, that cubic term, plus the quadratic term of 36x squared, minus the linear term of 54x can be rewritten as the quantity 2x, oops, my pen's not working too well, there we go, times the quantity 10x squared plus 18x minus 27. And let's look at this last one. Same thing. I have 15, I have 18, I have 8. 15, the factors of 15 are 3 and 5. I can divide 15 by 3 and get a whole number. I can divide 18 by 3 and get a whole number. But this 8 right here, 8 divided by 3 is not a whole number, so that's out. I can take 15 divided by 5, but this 18 here divided by 5 is not a whole number, so that's out. And the only other number that goes in 15 is 15. I could divide this by 15, but I cannot divide the other two by 15. So the only number I could factor out is 1. But then the question is, what about the variables? I got y to the 4th, y to the 6th, and y cubed. I could take 4y's from here. I could take 4y's away from here, but I cannot take 4y's away from there. So y to the 4th doesn't work. Likewise, the only one I could divide y to the 6th from is this one, but not the other two. But y cubed, I could divide this by y cubed. I could divide this by y cubed, and I could divide this term by y cubed. So if I factor out a y cubed, then what's going to remain is 15. These 3 y's will cancel out with 3 of these, gives me y. These 3 y's will cancel out with 3 of those, so it'll be minus 18y cubed. And these 3 y's will this y cubed will cancel out this y cubed plus 8. So my factored form for the trinomial will be y cubed times the quantity 15y minus 18y cubed plus 8. And that's how we factor those different polynomials by greatest common factor. Now I'm going to shift gears just a little bit, because now we're going to be factoring these polynomials by the greatest common factor. But we're also going to be factoring quadratics that meet certain conditions. And we're going to use a method called Xbox, or some people will call it diamond area. So I'm just going to call it Xbox. But to use Xbox, the X is what is known, some people will call factor diamond. There's the X in Xbox. All right, so with the X, or the factor diamond, the top cells contain the products of the numbers in the left and right cells, while the bottom cells contain the sum of the numbers in the right and left cells. So let's look at the example we got here. And number one, there's the left cell, there's the right cell value, 9 and 10. This top number right here, 90, you get that by taking the 9 times the 10. You take the product, you find the product of these two numbers. And you get the 19 here by taking the sum of the 9 and 10. So 9 plus 10 gives you 19. And that's the way it's going to work for all these X boxes. You got some value M, you got a number N. I shouldn't say number. You got some value M, some value N. It could be possible variables in there. But the top part of your X would be the product of M and N, and the bottom part of X would be the sum of M and N. So let's now look at number 2. This position right here will be the product of 8 times negative 7. Positive times negative is a negative. 8 times 7 is 56. And then down here, I would have 8 plus negative 7, which would give me positive 1. Let's look at number 3. This would be 7 times 6, which is 42. And then 7 plus 6 gives me 13. This part here, we usually don't list. I'm just putting it down there to just reinforce where that's coming from. Likewise, let's say, you know what, let's change this on your paper. Make that negative. So I got negative 9 as my value on the left side. I got positive 6 on the other side. So negative 9 times positive 6 will give me negative 54. And then negative 9 plus 6 will leave me with a sum of negative 3. So that's how you fill in the top part and the bottom part of this X, or the diamond, the factor diamond. We'll just call it the X. Make it easy for us. But sometimes the information is not so easy for us. It becomes more like a puzzle. Let's look at number 14. I have the value on the right side, 9. I do not have the value on the left side. But I do know that 9 plus the unknown number on the left side equals 8. Well, 9 plus negative 1 gives me 8. So this has to be negative 1. And then to find this top value here, I will go negative 1 times positive 9 gives me negative 9. So I completed my box. My X. All right, likewise, let's look at number 15. I got some unknown value there, but I know that 5 times the unknown value equals 10. Well, 5 times 2 gives me 10, so that's going to be positive 2. And then down here, I would go 5 plus 2, which gives me 7. And I got my diamond, or my X. Now, number 18 and 20 is the crux of where we're going when we factor quadratic. So what we need to do is find a number like m plus n, that gives us negative 1, and value of m times n, that gives us 20. So what I need to do is, I'm going to focus on this right here. I want to find the factors of, negative 20. So we want two numbers that when we multiply them together, we get negative 20. So first thing is, let's find the factors of 20. What two numbers are there? 1 times 20 gives me 20. 2 times 10 gives me 20. And 4 times 5 gives me 20. But I want to end up with a negative 20. So if I want negative 20, then these factors have to be opposite sides, because a negative times a positive will give me negative. So let me try this. Let me put the negatives there. So if I go 20 plus negative 1, or negative 1 plus 20, and I put the pluses here, that'll give me 19. That'll give me 8. That'll give me positive 1. But I want to end up with a negative 1 there. So it doesn't look like the signs are correct there. But what if I were to change the signs? What if I make the larger factor negative, and the smaller one being positive? Then I'll have 1 minus 20, which gives me negative 19, 2 minus 10, which gives me negative 8, and 4 minus 5, which will give me negative 1. And here are my factors. Those two numbers will give me, when I multiply those two numbers together, the 4 and negative 5, I get negative 20. When I add them, I get negative 1. So that makes the condition true. And let's look at, I'm going to erase these factors here. So if you need to, stop the video, back up a little bit, copy that down if you need to, and then play until you get to this point. Now, thing is here, once again, I need two numbers that when I multiply them together, m times n, I get 90, and when I add them, I get 19. So my factors of 90 are 1 and 90, 2 and 45, 3 and 30, 4 does not go into a 90 even amount, 5 goes into it 18 times, 6 goes into it 15 times, and 9 goes into it 10 times. Since my product is positive, the two factors are going to be have the same sign. They'll either be both positive or both negative. Let me just show you what happens when they're both negative. If I take negative 1 times negative 90, I get positive 90, which meets our condition here. But if I go negative 1 plus negative 90, I'll get negative 90. My pen, come on. Anyway, I get negative 91. This sum here has to be positive. So I'm not going to make them both negative, but I'll make them both positive. So the question is, which set of numbers, when I add them together, would give me 19? 3 plus 30 is 33. 5 plus 18 is 23. 6 plus 15 is 21. 9 plus 10 is 19. Ding, 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 winner. Put positive 9 there, put positive 10, or vice versa. You can put the 10 on our side and 9 on our side. Doesn't not matter. But the thing is, we got the 9 and 10. All right. So we're going to do some practice now on this, reinforcing it. And your next note you're going to be doing will be on factoring quadratics. Have a good day. Bye-bye.